Episode 11: Longitude Navigation and Accurate Time. By the 18th century, clocks had become more accurate than ever before. The pendulum had transformed timekeeping on land, allowing scientists, astronomers, and ordinary people to measure time with far greater precision than earlier mechanical clocks could manage. But there was still one place where accurate timekeeping remained extremely difficult: at sea. For sailors crossing the oceans, navigation was a matter of life and death. Once a ship lost sight of land, it entered a vast and dangerous world where a small error could become a disaster. A captain might believe he was safely on course, yet actually be many miles away from where he thought he was. Finding latitude, the position north or south, was relatively straightforward. Sailors could estimate it by observing the height of the sun at noon, or by using stars above the horizon. Longitude, the position east or west, was far more difficult. This became one of the greatest navigation problems in history. The Earth rotates once every 24 hours. That means it turns through 360 degrees in one day, or 15 degrees every hour. So, in principle, longitude could be found by comparing two times: the local time on the ship and the time at a known fixed location, such as London or Greenwich. If the ship's local noon occurred later than noon at Greenwich, the ship was west of Greenwich. If it occurred earlier, the ship was east. The difference in time could be converted into distance around the Earth. The idea was simple. The problem was the clock. A clock used at sea had to remain accurate while the ship rolled and pitched in rough weather. It had to survive changes in temperature, damp air, vibration, and months away from land. Pendulum clocks, so useful on land, were unsuitable on a moving ship. The motion of the vessel interfered with the swing of the pendulum, making accurate timekeeping almost impossible. This mattered enormously. An error of 1 hour meant an error of 15 degrees of longitude. Even an error of 4 minutes meant about 1 degree of longitude, which at the equator is roughly 60 nautical miles. A few seconds could still mean a position error of a mile or two. For a ship approaching rocks, reefs, or a dangerous coastline, that difference could matter. In 1714, the British Parliament passed the Longitude Act, offering a large reward to anyone who could produce a practical method for finding longitude at sea. Many people believed the answer would come from astronomy, using the moon, stars, and complex calculations. These methods were possible, but they were difficult to use on a rolling ship in poor conditions. Then came John Harrison, a self-taught clockmaker from Yorkshire. Harrison believed the answer was not in the sky, but in a clock accurate enough to carry the time of home across the ocean. For decades, he worked on a series of remarkable marine timekeepers, each one improving on the last. He designed mechanisms to reduce friction, compensate for temperature changes, and keep working despite the movement of a ship. His most famous timekeeper, known as H4, looked more like a large pocket watch than a traditional clock. It was not perfect, and it was not accurate to within a second over many years. That level of accuracy belongs to much later technologies, including quartz and atomic clocks. But for the 18th century, Harrison's achievement was extraordinary. H4 was accurate enough to solve the longitude problem in practical terms. For the first time, sailors could carry reliable time across the oceans. By comparing the time shown by the marine chronometer with the local time found from the sun, they could calculate their longitude far more accurately than before. The consequences were enormous. Ships could travel with greater safety, trade routes became more reliable, naval power became more effective, exploration became less uncertain. For Britain, an island nation with growing global ambitions, accurate navigation was essential. Without reliable timekeeping, long-distance sea travel remained far more dangerous and uncertain. This was one of the great turning points in the history of time. A clock was no longer merely something that told people when to work, pray, trade, or meet. It had become a tool for finding position on the surface of the Earth. Longitude showed that time and place were deeply connected. To know where you were, you needed to know what time it was somewhere else. Harrison's work did not end the search for better clocks. It opened the door to even greater precision. Later engineers would refine marine chronometers, and later still, new technologies would push accuracy far beyond anything possible in the 18th century. But the essential breakthrough had been made. Accurate timekeeping had helped humans cross the oceans with confidence and had changed navigation forever. In the next episode, we'll discover how railways, industry, and growing cities created a new problem: the need for everyone to agree on the same time. If you're enjoying this journey through time, please subscribe and click the notification bell so you don't miss future episodes. And if the next episode is available, you'll find it linked on screen. Thank you for watching.